Well, howdy there, Internet students. It's Mr. Hermanson again. We are going to continue with exponential growth and decay relationships. Today we're going to learn how to recognize graphs and tables of exponential growth and decay situations. And hopefully by the time we're done here, you'll be really good at recognizing them and writing equations for them. Okay, we're going to do a little zombie math right now. There is an epidemic of zombie attacks around Halifax high schools. The zombies especially like the brains of math students, but can only infect one person each day. After attending a professional development session, Mrs. Service was infected and is now searching out victims in her math class. So she can infect one person per day. All right. And then remember, each person who's infected can infect one person. So go ahead and see if you can fill in that table. Before you make the graph, make sure your values are correct by checking with mine. All right, here's how I got it. And one thing I want you to realize is we're multiplying by 2, right? So if we're going to just figure out what expression will give us the nth number, the nth day number of zombies, and that would be 2 to the n because we're repeatedly multiplying by 2. All right, go ahead and fill in these answers. You can check back and see if you agree with mine. All right, here's what my graph looks like. And it's a nonlinear graph. The equation is 1 times 2 to the x, or 2 to the x. Since we start with 1, you don't really need that there. 2 to the 9th equals 512, so that would be 9 days. All right. If 1,231 students were enrolled at Citadel, approximately how many days until they are all infected? Well, we saw that on the 10th day there were 1,024, so it would be somewhere between the 10th and 11th days. All right, suppose that 3 teachers were infected at the session. Now each person will be able to infect 1 person per day, so each of those 3 are going to infect 3, so there will be 6 infected on day 1. Go ahead and fill in the rest of that and make the graph. All right, so here's what your table should look like. You should notice that we're doubling again. And the graph kind of looks the same, except that it just starts a little bit higher. Okay, so go ahead and fill in the next few questions. All right, so here's the function that describes that situation. Instead of starting at 1, we started at 3, but we're still multiplying by 2. You're going to fill in these, and I'll just show you how to do this. So you have to do 3 to the 0 here, which is 1. 3 to the first is 3. 3 to the second is 9, and so on. Then you're going to graph those. Same here, and you can just use your calculator to get these. 0.5 to the 0, of course, is 1. 0.5 to the first is 0.5, and so on. Okay, so go ahead and fill those in and make the graphs. So here's what your graphs look like. So what we can learn from that is that this is a growth graph, exponential growth. This is an exponential decay graph. The reason we know that this is a growth graph is because in this one we're multiplying by a number above 1. And in this one, we're multiplying by a number less than 1. All right. So you can answer these questions. All right. We know any number to the 0 is power is 1. So they got to start at 1 if you are just doing something to a power. All right, for this set, we're going to state whether we have an exponential relationship or not. Here's your clue. If it's exponential, you should be able to write it this way. So you should have a x as a power, you should have a base, and then you may or may not, if it starts at 1, it could just be whatever you're multiplying, like 2 to the x power, like that. If it starts at a number different than 1, then this would be your y-intercept. But pick the ones you think look like that. Make sure they have x as the power. So all the ones I circled have x as a power, so they're exponential. Now the way I tell if they're growth, whatever you're multiplying by, the b part, so b is greater than 1 when it's growth. When it's decay, b is between 0 and 1. All right? Now, you're going to try and decide if these tables are exponential. So in other words, is there a common multiplier? So what you're going to need to do is divide. So we're going to do 9 divided by 6, which is 1.5. And then we're going to do 12 divided by 9, which is 12 divided by 9 is 1.33. So since I didn't get the same number to multiply by, we're going to say no, it's not exponential. Okay? So we're not going to worry about whether it's growth or not. So do that, divide the numbers, see if you have a common multiplier. If you do, and then you're going to be able to tell if it's growth by what you're multiplying by, or whether or not the numbers are going up or down. So go ahead and check those. All right, you should have noticed that in both tables they are exponential because there's a common multiplier. This one you're multiplying by 1.5 every time. This one you're multiplying by 0.5 every time. When you're multiplying by 1.5, you're going to have numbers that go up, so we call that growth. And when you're multiplying by 0.5, you're going to have numbers that go down. We call that decay. Okay, pick the graphs in here that represent exponential relationships. Go back and look at the graphs that you created for the zombie situation and those other ones. So look at what those look like. Decide whether or not you think it's exponential. Okay, 1 and 4 are exponential graphs. They just have that one curve to them. And number 1 is growth, and you can tell because it's going in an increasing direction. And number 4 is decay, and you can tell because it's going in a decreasing direction. All right. For this situation, these are my notes from a bacteria experiment I was doing with some cultures, and I ended up spilling some coffee on them, so I lost some of my values. But I didn't know this was exponential, so just because I knew that, I was able to kind of check and guess and figure out what the missing numbers were. Okay, and here's how I did it. Like on this one, I could tell that since I knew it was exponential, I knew that this was multiplying by 3. So I just kept multiplying by 3 to fill in the numbers. Now some of you might say you're adding 200, but you're not, because if you're adding 2 numbers, that'd be linear, not exponential. So don't try and add the same amount every time. You're multiplying by some number every time. Now remember, to figure out what you're multiplying by, you may divide. And when you're done, what I'd like you to do is, well, go ahead and fill in the answers to as many of these as you can and make your graphs. Okay? All right, before we move on, I'd just like to make a couple comments here. So they all start at 500, so all the equations have that. They all, we're going to use the number of days as the exponent, so they're all the same. And then the factors, the number we multiply by, you'll notice that those are 3 and 5 for the growth ones, and 0.5 and 0.7 for the decay ones. When you make your graph, you can't fit very many of the data points on there. So, but those are the two growth ones. And now to do the two decay ones, again, you're going to start at 100. And the one that multiplies by 0.5 goes down to 50 after 1 day, then down to 25, then down to 12 and a half. So that's that one. You can go ahead and do the other one and answer those. All right, the growth graphs are increasing, the decay are decreasing. All the y-intercepts on every graph is 100. They're all the same. They start at 100. You might have noticed that the higher the growth factor, the steeper the graph. And that the smaller the decay factor, the steeper the graph. All right, so growth equations, here's an example, and you can just take it from the ones we just did. You need to have a number that you're multiplying by greater than 1. Decay, you need to have the number you're multiplying by between 0 and 1, so something like 0.5. Okay, a growth graph curves, but it curves in an increasing direction. And a decay graph curves, but it curves in a decreasing direction. All right, I think that's all I got for you today. You can go ahead and work on your assignment, and we'll talk to you soon.